Hello and welcome to day 10 of my Advent of Code series for 2020. Today we are going to tackle adapter array, but if you haven't seen any of my previous videos, you can get caught up by checking out the playlist linked right up there. And be sure to get subscribed and turn on post notifications for my channel so you don't miss any future uploads. So today we are patched into the aircraft data thing that we are trying to get patched into before, but our device is dead and we want to charge it. But the problem is the charging outlet near our seat has an effective joltage of 0, and our device requires a higher joltage. We'll get into what it is in a second. So we have a bunch of adapters in our bag, and how an adapter works is it can accept a joltage of anything up to 3 lower than its rated output, and it outputs at its rated output. So then our device also has a joltage adapter built in that is rated for exactly 3 joules higher than whatever our highest adapter is. So for this, we want to test all of our adapters at once. So we're going to have them all plugged into each other. And to do that, we are then going to want to check how many times we jump by 1 jolt and how many times we jump by 3 jolts and multiply those numbers together for our solutions. So there is an example here that sort of works through it. I'm not going to go over it right now, but you can go ahead and check it out if you haven't already. I recommend you go ahead and try this problem out for yourself before reporting back to see my solution, which we are going to jump into right about now. So the first thing that's slightly different here is how I am reading in adapters. So normally I would just read back the list, maybe convert it to an int in there, and that's it. But this time we are going to sort the list and then also add a 0, which is the output joltage of the wall, to the front of that list. So then once we have that done, we go ahead and pass that sorted list starting with 0 into our part1 function. Here I initialize a dictionary called diffs that holds how many different times we jumped by 1 jolt, 2 jolts, and 3 jolts. And you'll see that I'm starting off the 3 jolts one with 1, because if we remember, our final output from our final adapter to our device is a jump by 3 every single time, regardless of what our input data is, so we can go ahead and safely do this. So then what we do is we go ahead and loop through from the second element of our array, so the first thing that's not the wall, our first adapter, until the end of the list. And what we're doing there is we are adding to our diffs value for whichever adapter we are up to. So for example, so what that's going to be is whatever we are currently up to in our adapters minus the previous thing in our adapters. We are adding a 1 to that list. You could also do this with a counter from collections if you want, but I'm trying to avoid using external libraries here and do everything in as vanilla Python as I can for as long as I can, so that it's more accessible. So then we finally return our number of times that we jump by 1 times our number of times that we jump by 3, and we get our correct answer. So then we can jump into part 2. So in part 2, we are trying to find, instead of what our longest run is, how many different kind of runs there are. So if you'll remember, we can jump by anywhere from 1 to 3 jolts. So for example, in this first example, there are 4, 5, 6, and 7 are all options. So from 4, we can either go by 1 jolt to 5, by 2 jolts to 6, or by 3 jolts to 7. So since we have that, there end up being a bunch of different options for how to go through this entire list of adapters, and our job is to find just how many options there are. So I recommend you go ahead and give this a try. It's a bit more difficult, but there are a lot of different ways to solve, and we will jump into my code and exhibit my solution right about now. So for part 2, I saw a lot of people using either like a dynamic programming or other recursive approach, and I found that that was just completely unnecessary for this problem and just adds runtime and just complexity for no reason. So this is my linear solution for how to do it. So what we do is first I initialize an array called paths, and what paths is going to hold is how many different ways there are to get to whatever index corresponds in adapters from all of the previous things. So we start this off with a 1 because there is one way to get to the 0, which is the first wall thing, and then we add in a bunch of zeros for the rest of the adapter things. So then what we are doing is we are looping through our adapters, and we are then looping through all of the indices that are 3 lower. So we're checking if those are within 3, that means that they are possible to get from that adapter to our current adapter. Then we are adding the number of ways that there are to get from the adapter that came before to our current adapter. So let's say, for example, we had a run of like 1, 2, 3, 4, 5, right? So, well, all of our things start with 0. So 0, 1, 2, 3, 4, 5. So as we see here, we have already initialized that there is only one way to get to 0. And then if we jump over to 1, which is going to be the next thing in our loop, the things that are in range of it for that is only 0. And so there is one way to get from 0 to 1. Well, there's one way to get to 0, and then we can get from 0 to 1. So we go ahead and add the different ways that there are to get from 0, which is just 1, into 1. So that's also going to be 1. So then we get up to 2. So 2, there are two different ways to get to, because both 0 and 1, both 0 and 1 are in range for it. So we go ahead and add the ways to get to each of those to 2, which is going to be 2. So then from 3, there are 3 ways to get to it. We can go from 0, from 1, or from 2. So we add all of those possibilities. That's going to be 1, 1, and 2, which is going to give us 4. So you may notice that since I chose here, well, let's add an example just to break this pattern. We'll put an 8 at the end. So then from 4, we're going to be able to get there from 1, 2, or 3. So we add all of these together to get 7. And then from 5, we can get there from any of these 3. So that's going to be 13. And then to get to 8, there is only going to be one way, and that's from 5. So then that is only just going to copy down that 13. So you may notice whenever there is a run of just ones, it is actually just a Fibonacci sequence. But then whenever we get to runs breaks by either 2 or 3, that's going to break. So that's why I did it like this instead of actually just yielding the Fibonacci number. So that is going to be that, and then eventually we get to our final thing in the array, and that's going to contain how many paths there are to get to that last adapter, and we know that the only way to get to our device is going to be the same way that we get to that final adapter, so we just return that, and that is our answer. So that is what we got. And I hope you enjoyed this video. If you have any questions about this implementation, feel free to ask in the comments, because I understand that it may be slightly confusing. I hope you enjoyed. Be sure to get subscribed so you don't miss any future videos, and like this video if you enjoyed it. And I will see you in the next